All right. So as we begin, I just wanted us to take some time again to make sure we have in the notes and make sure you're writing the page number of which you're going to be writing it in. All right. So Unit 2, 2.08, the greatest average rate of change. So example 1, which function has the greatest average rate of change over the interval -3, 1? We're going to understand what this means graphically through a table and through a function. So I want you to pause the video right now and make sure that you have all this set up. Okay, so let's begin. Learning that we have an interval, we deal with x values. And so here is x equals -3 and +1. And so when we're looking at the graph, where is x -3? 2, 3. That's at this corner point at -3, -1. And 1 is going to be here at 1, 1. So these are the two corner points that I'm going to be focusing on. For the xy table, -3 is right here at -3, 9. And +1 is here at 1, -3. And so we're going to do that function later, but in both of these cases right now, we're solving for slope. So first step is to identify the points. Second step is to solve for slope. So if we can call slope is y2 minus y1 all over x2 minus x1. And so I'm take my y2 subtracted by y1. That's y minus -1 all over x2 minus x1. 1 minus -3. That becomes 1 plus 1 over 1 plus 3, because when we subtract the negative, we add the values. That becomes 2/4 or +1/2. All right. Moving on to the next one. It's -3 minus 9. So -3 minus 9. 1 minus -3. So rewriting it because I see as negative being subtracted by negative. Subtracting negative, so we add the values, and now let's operate. -3 minus 9 is -12. 1 plus 3 is 4. That gets me -3. All right. So now once we have solved the slope of the graph in a table, we're now going to focus on the f of x, the function. And so f of x equals x squared plus 4x minus 7. So we're going to solve for f of -3, which equals -3 squared plus 4 times -3 minus 7. F of -3, -3 cubed squared is 9. 4 times -3 is -12. And then minus 7, we bring it down. F of -3, 9 minus 12 is -3. -3 minus 7 is -10. And so we have a corner point of -3, -10. We're now going to do the same for f of 1. So now it's going to be 1 squared plus 4 times 1 minus 7. So f of 1 equals 1 plus 4 minus 7. F of 1 equals 1 plus 4 is 5. 5 minus 7 is -2. Corner point here is 1, -2. And so in all cases, our first step is to identify the corner points given the interval. So we have now -3, -10, and 1, -2. So our first step is to identify 2 points given the interval. And whether that's plotting on a graph, identifying x and y table, or solving through each x values and corner points as such on a function, we're going to gain those corner points. Second step is to solve for slope. And -2 minus -10, 1 minus -3. So m equals -2 minus -10, and 1 minus -3. I'm subtracting by a negative, so I need to add the values. -2 plus 10 is 8, 1 plus 3 is 4, m equals 2. And so now we have all the slopes, right? So in class I would ask you, out of these three, which is the greatest? And it's going to go Most people are gonna say we're doing least to greatest here. Yeah. From least to greatest, people tend to say -3 is the least. So and then 1/2, and then 3, because -3 is less than 1/2, which is less than 2. Right, but that is comparing slopes. When we're comparing average rate of change, we take the absolute value of every single term. And so the absolute value of positive 1/2 is positive 1/2. And that is absolute value of -3 is positive 3. And the absolute value of positive 2 is positive 2. And so two things about absolute values: it's always going to be the positive value of that input, and it's always the difference between that number and 0. So 1/2, 2, and 0. Concluding that from least to greatest, it's going to be 1, 3, and 2. That's 1, 3, and 2 from least to greatest. Concluding that when comparing the average rate of change, AROC, is comparing the absolute value of the slope between 2 points of an interval. Yeah, this one's a fun one. All right, so thank you so much, and have a great rest of your day. Have the whole notes as such for your viewing pleasure.